Hi there and welcome to the video. In this video we are going to be looking at the laws of indices, and then we are going to extend those laws of indices to slightly more complex questions. Okay, the first question on the screen asks us to multiply a to the power of 5 by a to the power of 2. So this is the first law of indices, and what the first law of indices tells us is when we are multiplying indices and they have the same base letter or base number. So in this question, the base letter is A. You can see that they're the same. When the base letters are the same and it's a multiplication question, we can simply add the indices. So the answer to this question would be simply A to the power of 7. So the first law of indices tells us when the base letter or base number is the same, during a multiplication question, we can add the index numbers. We can add the indices together, giving me an answer of A to the power of 7. The second law of indices is sort of the opposite of what we just talked about. This time it's a division question, and rather than adding the index numbers, we are going to subtract the index numbers. One thing to notice in this question is there's no index number on this base letter B. When you have a question with no index number, it actually means B to the power of 1. So we need to assume that there is a 1 where I've just put this yellow dot. So what we're actually going to do in this calculation is 6 minus 1 to tell me that the answer is B to the power of 5. So B to the power of 6 divided by B to the power of 1 is going to leave me with B to the power of 5. That is the second law of indices, telling me that when it's a division question, I can subtract the index numbers. The third law of indices deals with when we have a base letter and an index number inside some brackets. So y to the power of 4 all to the power of 5. In this case, the law tells us we can multiply the index numbers. So I'm going to multiply the index number inside the bracket by the index number outside of the bracket. So 4 times 5 is going to tell me that the answer to this is y to the power of 20. So just to highlight at this point, in the questions on the first law, there is a multiplication sign, yet you do an addition. And in the questions where we include brackets, there is no multiplication sign, yet we go ahead and do a multiplication. And that's the summary of the 3 basic laws of indices. We can see why this third law of indices would work if we look at the maths involved, because we've essentially got y to the power of 4, which mathematically is y times y times y times y, 4 times. And then if we had those 4 y's 5 times, we would essentially have 20 y's altogether, which leads us to doing the multiplication, which leads us to y to the power of 20. Okay, so let's get a little bit more difficult now. If we look at the top question, 2e to the power of 3 multiplied by 4e to the power of 5. Okay, first thing here is to know which is the base number or letter and which is not the base number or letter. In this question, the E is the base letter. The 2 and the 4 are not base numbers because the index number is not attached to the 2, and the index number here is not attached to the 4. When we get a question like this, we separate it into two separate questions. So for example, what I'm going to do is I'm going to forget about those e's. So I'm just going to think about the numbers. 2 times 4 is going to give me 8. Then I'm going to forget about the numbers. And I'm going to have e to the power of 3 multiplied by e to the power of 5. Remembering the first law of indices tells us to add those index numbers, giving me e to the power of 8. So the answer to that first question is actually 8 e to the power of 8. The 8 comes from multiplying the numbers together, and the e to the power of 8 comes from using the laws of indices on the base letter e. Let's do the same for the second question. Just going to hide the b's, so I'm left with 6 times 3. Okay, that's going to give me 18. Then I'm going to hide the numbers. B to the power of 3 times b to the power of 2. It's a multiplication question, so I'm adding the indices together. That's going to give me 18b to the power of 5. I'm going to apply the same method to the third question. I'm going to hide the b's. 12 divided by 3, it's a division question this time, is going to give me 4. So I divide the numbers as normal. And then I take a look at the letters. B to the power of 6 divided by b to the power of 2. Because it's a division question, I'm going to go ahead and subtract the indices. It's going to leave me with b to the power of 4. So my final simplification here would be 4b to the power of 4. Same method for the fourth and final question. If I hide the b's, you can see I'm left with 3 squared. 3 squared being 9. Then if I hide the 3, b to the power of 3, all to the power of 2. I'm dealing with brackets this time, so I'm going to multiply 3 times 2. It's going to give me b to the power of 6. So the answer to that final one would be 9b to the power of 6. It's a very common error in these sort of questions to remember to multiply the indices, but to forget to raise this number also to the power. So the 3 squared, just make sure you're remembering to do that part of the calculation. Okay, so there is some slightly harder index laws. Okay, for each of these questions, I'd just like you to pause the video for maybe 30 seconds, answer the question on the screen, and then I will show you my solution. Could you pause the video now? Okay, welcome back. So first of all, I'm going to multiply the 3 times the 4, which is going to give me 12. A cubed times a squared. I'm going to add the indices to get a to the power of 5. So that is essentially the working out. That is what I'm doing in my head. This calculation for the numbers and this calculation for the base letter A. Then I'm going to put my two answers together. 12a to the power of 5. Again, could you briefly pause the video and have a go at this question? Welcome back. The two calculations you should have been carrying out here are a division with the numbers, 14 divided by 7, which is going to give me 2. B to the power of 3 divided by b to the power of 5. So the calculation I'm doing is 3 take away 5. I'm actually going to end up with a negative index number, which is fine. That will be totally correct for this question. When I simplify to get my final answer, I end up with 2b to the power of negative 2. Very well done if you were not put off by this negative index number. Could you pause the video and have a quick go at this question? Okay, welcome back. So the two calculations you should be doing this time, look like this. 3 cubed, and then z to the power of 4 all to the power of 3, which is going to lead me to multiplying the index numbers 4 times 3. When I put my answer together, 27 z to the power of 12. The 27 comes from 3 cubed, which of course means 3 times 3 times 3. Give me an answer of 27. Very well done there. Okay, I've placed 6 questions on the screen. I would like you to pause the video at this point. I would like you to answer all 6 questions, simplifying the indices, showing me your full working out for each question. Could you pause the video now, please? Okay, welcome back. I'll just go ahead and show you my answers. My answers look like this. So if you could just take a bit of time to mark up your answers. Just briefly want to talk about one of the questions. This question here, when we're dealing with the base letter y, because it's a division, we are going to do a subtract. So we're actually going to end up with 2 take away negative 3. So we're going to end up with 2 subtract negative 3. Our understanding of maths tells us that 2 negative signs would make a plus, which is why we've ended up with y to the power of 5. So just make sure you didn't fall into that little trap there, and remembering that 2 negatives when next to each other in a maths calculation would become a plus, would become an addition. Very well done if you were able to answer all 6 of those questions. Here is your next task. So on the left-hand side of the screen, there is 6 indice questions, and on the right-hand side, there are 6 answers. I would like you to match up the question to the answers, but one of the questions is the odd one out. So one of the questions does not pair up. So could you match up the ones that do, and also highlight the odd one out that does not match up? Could you pause the video now, please? Okay, welcome back. I'll just go ahead and show you my pairings. Looking something like that. So the question that was the odd one out is this question here. You can see that if I did 16 divided by 8, I would get 2. A to the power of 6 divided by a to the power of negative 2, that would become 6 take away negative 2. So again, we're talking about those 2 negatives making a plus, which would take me up to 2a8 and not 2a to the power of 4. So very well done if you were able to identify that this was the odd one out. It did not match up correctly. And you can see the other matchings on the screen there as well. Remember, for this one in particular, quite a common mistake is forgetting to do the 2 cubed, which in this case would be 8. Very well done if you were able to match all of those together. Okay, so let's take simplifying indices one step further. Very common questions that you might get in tests or exams look like this, where you're asked to use more than one law of indices to fully simplify a calculation involving indices. Okay, so let's have a look at this question here. First thing I'm going to do is I'm going to think about the numerator. I'm going to simplify the numerator. It's a multiplication question, so I'm going to add the indices together. Separately, I'm also going to think about the denominator. A to the power of 2, all to the power of 3. It's in brackets, so I'm going to multiply the indices together. So you can see what I'm left with is a to the power of 9 when I've added the 4 and the 5, and a to the power of 6 when I've multiplied the 2 and 3. Now what I'm left with here is this fraction line, remember, of course, also means divide. So what this is actually telling me is a to the power of 9 divided by a to the power of 6. Using the laws of indices, when it's a division question, we would subtract the index numbers. So you can see here, I've just rewrote it as a division. So this and this are equivalents. I've just wrote it with a division sign, reminding myself that 9 subtract 6 due to the law of indices would tell me that the fully simplified version of this would be a to the power of 3, and this would be my final answer. The important word in this question is fully simplify. So if you just took it to this stage, yes, you have simplified the question, but you have not completely and fully simplified the question. This is where you would get your full marks. Okay, if you want to have a go at this question yourself, you can just pause the video here. Otherwise, I will also talk through this question. First of all, I'm going to look at the numerator because it's a multiplication question. 6 add 5 is going to give me e to the power of 11. For the denominator, remember this should be e to the power of 1, and I'm going to subtract the 5, leaving me with e to the power of negative 4. So I'm left with this. I'm just going to rewrite that, showing my division sign. So now I'm left with 11 take away negative 4. Two negative signs next to each other results in an addition. So 11 add 4 takes me to e to the power of 15. Very well done if you answered that in front of me and got that one correct. Again, if you want to have a go at this question before my answer, just pause the video now. Otherwise, I will talk through this example. I'm going to look at the numerator. 2 times 6 is 12, and 3 add 7 is 10. So I'm going to be left with 12a to the power of 10. On the denominator, 2 squared is 4, and 4 times 2 is 8. So I'm going to be left with 4a to the power of 8. So this is my first step. I'm just going to write it out with a division sign. So I'm left with this. 12 divided by 4 is 3. A to the power of 10 divided by a to the power of 8. I'm essentially doing 10 take away 8, leaving me with a to the power of 2. 3 a to the power of 2 is the fully simplified answer. Okay, so here is another task for you to have a go at. So for each of these 6 questions, I would like you to fully simplify the indices down to its simplest form, following the examples I've just been through on the previous few slides. If you could pause the video at this point and have a go at fully simplifying these indices. Okay, welcome back. I'll just go ahead and show you my solutions. So here are my fully simplified answers. Just a little reminder here that when you do not have an indice, we assume that the index number is 1. Very well done if you were able to find all 6 correct answers here. One more task to move on to, and we will have a little look at some IGCSE exam questions. So on the screen, I've displayed 3 challenging exam questions which ask you to use your knowledge of indices from this video. I'd like you to pause the video at this point and have a go at answering all 3 exam questions. When you unpause the video, I will show you my worked solutions. Could you have a go at these questions now? Okay, welcome back. Let's have a look at the first one. So here is my fully written solution. You can see I've ended up with 28 divided by 4, giving me a 7. And then I have also took the base letter x and subtracted 1 from 5 to give me x to the power of 4. And then I've also dealt with the base letters y, 3 take away 2, leaving me with y to the power of 1. So this is my final answer. So we separate this question into 3 parts. There's your first part. Then we look at the x's for the second part. Then we look at the y's for the third part. So very similar method to what's happened in previous questions in the video, but this time we're dealing with 2 different base letters. For the second one, we need to work out what number would go here in order for my final index number to be a 4. So you could just have a think about that and decide what number, when you add it to 3 and then subtract 6, you're going to be left with 4. Or you could apply a bit of mathematical notation by creating an equation. So what I've done here is I've basically multiplied both sides by 5 to the power of 6, which resulted in this multiply by 5 to the power of 6. And then I've equated the index numbers at this point to find that n would have to be 7. But again, you could have thought about it. What number here, when I add 3 and subtract 6, is going to leave me with 4. So you just needed to show some understanding of the laws of indices. For the third question, this is my working out. If we approach it in a similar manner to this one, we are going to end up with 8 to the power of 5 by adding these two together. And then on the bottom, we have 8 to the power of 4. We're left with a division, so we're going to do a subtract. So we're left with 5 minus 4 gives me 8 to the power of 1, which is great. That's a good answer. However, this question actually wants the base number to be 2. And we've ended up with the base number 8. But we do know that 8 is exactly equivalent to 2 cubed. So all I've done there is I've replaced the 8 with 2 cubed, because 2 cubed equals 8. So therefore, my value of n will be 3. So we're applying the laws of indices, and then we're just manipulating our answer to be given with a base number 2 rather than 8. Very well done if you were able to answer those 3 difficult exam questions. Hopefully now you understand the 3 basic laws of indices, and you're also able to have a go at some increasingly complex simplifying indices questions.